We all expect our databases to be reliable. We expect them to keep our data safe. I mean, that's table stakes, right? But what really separates a basic database from a truly powerful one? Well, it's all about the features that make them secure, collaborative, and, honestly, a dream to work with.
Think about it like this. Any old car can get you from point A to point B. It functions. But a modern car, that's a completely different experience. You've got advanced safety features, an amazing sound system, navigation that just works. It's about more than just the basics. And believe it or not, the exact same thing is true for databases. It's those upgrades that make all the difference.
Okay, so let's get into it. Now, if you've been around databases, you've definitely heard of ACID properties. Think of those as the fundamental safety rules of the road. They're the seatbelts, the airbags, the stuff that guarantees your data is safe and sound. But today we're going to pop the hood and look at the upgrades. These are the high-tech features that really define a modern, powerful database management system, or a DBMS.
So first things first, let's talk about the absolute foundation. In our car analogy, this is the chassis and the engine. It's all about having a rock-solid blueprint that makes sure everything is organized perfectly and runs with absolute precision.
And the very first part of that blueprint is the idea of relation-based tables. It might seem simple now, but before this, data was a total mess, just a bunch of disconnected files. This brilliantly simple structure brought order to all that chaos. All your data is neatly organized into tables with rows and columns, creating these really clear relationships between everything.
And here's a perfect example that makes this super clear. Just picture a university student database. Every single student gets their own row, right? And then their info, ID, name, grades, is all sorted into these nice, neat columns. It's just an incredibly clean and effective way to manage what could otherwise be really complex information.
All right, now for the engine. See, it's not enough to just store data. That data has to be accurate. If your data is wrong, you get bad reports, which can lead to some, pretty disastrous business decisions. This is where consistency and integrity come in. They're like the database's own internal quality control system, enforcing rules to make sure only good, valid data ever gets in. And this example just nails it. Can you even imagine the chaos if two students had the same exact ID number? It would be a nightmare. Well, integrity rules make that scenario totally impossible. The system just automatically rejects any duplicate entry. It's a simple but absolutely crucial automated safeguard. So we've built our chassis, we've got our engine running smoothly. Now let's hop inside the car and check out the features that really define the user experience. We're talking about how we can all work together inside the cabin and how it keeps us and our data protected. Modern work is all about collaboration, and this feature solved a huge problem with older systems where, get this, only one person can make changes at a time. Multi-user access means lots of people can be in the system at once, reading data, writing data, all without tripping over each other. The system is smart enough to manage any potential conflict, so everything just works. Just think about a big online store during a sale. You've got someone in the warehouse updating stock levels as things are shipped out, while at the same time, someone in marketing is pulling a sales report. They can both be working with that inventory data simultaneously. No problem. This feature is absolutely essential for keeping up with the pace of modern business. But of course, the more people you let in the car, the better your locks need to be. This is the advanced security system for our database. And in a world with so many data privacy laws, security isn't just a nice-to-have, it's a legal requirement. Things like encryption scramble the data itself, but role-based access controls, that's like a smart key system, making sure people can only open the doors they're actually authorized to. So here's the bottom line. Not everyone gets the same key. In a company, the HR manager has a key that can unlock really sensitive stuff, like employee salaries. But a regular staff member, their key just won't work on that door. That kind of specific granular control is totally fundamental for protecting private information. All right, we've covered the cabin. Now, let's get behind the wheel. How do we actually drive this thing? This next set of features is all about the control panel, how we tell the database what to do, and just how flexible it is when things need to change. So, the main control panel for almost every modern database is SQL, which stands for Structured Query Language.
It's the steering wheel, the gas pedal, and the dashboard all rolled into one. And because it's a standard language, a developer can use the exact same skills on tons of different database systems. It's basically the universal language for speaking to data.
And with SQL, you can ask incredibly specific questions. You can type in a simple command that says, hey, show me every single customer who bought something in the last 30 days, and boom, you get exactly that list, instantly. It's how you transform these giant mountains of raw data into real, actionable answers. Now, this last feature, this is a real game changer. It's called data independence. And what it means is you can make changes under the hood, you can tinker with the database's structure without having to completely rebuild the whole car. It creates this crucial separation between where the data is physically stored and the apps that actually use it. So let's say your business decides it wants to start collecting customer emails. With data independence, you can just add a new email column to your customer table. And here's the magic part. All of your existing software, like your sales dashboard or your shipping tools, they just keep on working perfectly. This kind of flexibility is what lets a database grow and evolve right along with your needs. Phew, all right, we have covered a lot of ground. We've gone from the blueprint to the cabin experience to the driver's seat. So let's pull over for a second and take a look at the complete spec sheet for our modern, high-performance database. Okay, here it is, the whole shebang. We've got relation-based tables to keep things organized. We have multi-user access, so we can all collaborate. We've got consistency and integrity to make sure our data is accurate, security to protect it, the SQL query language to interact with it, and finally, data independence for that all-important flexibility. And hey, to help make all this stick, here's a great little memory tip for you. Just remember these 6 keywords: organize, collaborate, validate, protect, query, and adapt. Each one really captures the essence of these features. It's a super simple way to remember what makes a modern database so incredibly powerful. So we've looked at the upgrades that define the databases we rely on today. But that leaves us with one last, pretty interesting thought. As technology just keeps accelerating and the amount of data in the world explodes, what do you think the next essential upgrade is going to be? What's the next must-have feature for the databases of tomorrow?